Welcome guys, Sizwesakhe at Sizwesakhe Academy, and this is the Global Classroom. Guys, we are still on arithmetic, and today we are doing basic laws of arithmetics. These are the laws. Let me just get down to it. Number one, it's commutative. Maybe let me say commutativity for first, because I said it's a law. Commutativity, but it's also known as commutative property. So if you are regarding it as a property, it's a commutative property. If you are taking it as a law, it's commutativity law. So it's still the same thing, still falls as a basic law of arithmetic, right? The second one is associativity or associative property. Associativity or associative property. The third one is called distributivity law, also known as distributive property. Right, so here are these laws. It's just three of them: commutativity law, associativity law, distributivity law, or you can call it a commutative property, associative property, distributive property. These deal with the arithmetic operation system, which is a plus, minus, multiply, and divide. Arithmetics is all about this, is the ability to use this in numeracy and get solutions. That is what arithmetics is all about. Arithmetics is a portion of mathematics. Let's go back to the very first law now and start dealing with it. So to explain what it means. So take it, we have a 4 plus a 5 is equal to, and we have a 5 plus a 4 is equal to. 4 plus 5 is a 9. 5 plus 4 is also a 9. So here we swap the numbers. That's what commutative is about. To see if we will still get the same results if we manipulate the numbers. If I swap the numbers, like if 5 was here, the second number, here 5 is the first number, 4 was the first, here 4 is the second. Let me just add 2. Since 4 here, we know that is positive, so we will say 2 plus 4. We put a 2 here and we put a plus 2 here. See, we put a 2 up front and we put a 2 at the end. Let's see if the results will be the same here. So we say 2 plus 4 is 6 plus 5 is 11. 5 plus 4 is 9 plus 2 is 11. It still gives us the same answer. So we can certainly say that a plus is commutative, because either way you put a number, you can take this 2 and put it in the middle, and 4 here up front and 5 there. Let me just quickly show you what I'm talking about. 2 in the middle, 4 here, plus 5 here. It will still give us the same answer, which is 11. 5 and 2 is 7 plus 4 is 11. So no matter which place you put a number on this, it still gives you the same. So you can play around with the numbers and it will still give you the same. Hence, we say positive is commutative. Let's go to our second one. We're dealing with positive. Remember, I told you that these deal with plus, minus, multiply, and divide. Let's follow with the multiplication now and see what happens. So let's say 4 times 5 is equal to, and 5 times a 4 is equal to. 4 times 5 is a 20, and 5 times 4 is also a 20. You see, we played around like we did in the addition. We are doing it on multiplication. We change the side, the numbers, it still gives us the same answer. Let's multiply with another 2 here and another 2 here. So 2 times 4 is an 8, times 5 is a 40. So we change here, it gives us a 40. 2 is up front. Let's see if 2 is at the end. 5 times 4 is 20 times 2 is a 40 again. So no matter how you place then your numbers, it still gives you the same answer. You manipulate the answer, the numbers, swap them around, they still give you the same answer. Right, let's go now. We've done multiplication, so we can say positive multiplication are commutative. So this is commutative, this is commutative. Let's see with the minus now, with the negative, if it will work. 4 minus 5 is equal to, and 5 minus 4 is equal to. 4 minus 5, we say we take the sign of a bigger number, which is minus here, and 5 minus 4 is 1. Put 1. 5 minus 4 is, it is 1. So the answers are not the same. If we check this on our number line, here is our number line, we have a 0, 1, 2, we have a 0, sorry, we have a minus 1 this side, and a minus 2 this side. So we have a positive 1 here, we have a positive 1 here, here is our positive 1. We have a negative 1 this side, here is our negative 1. So they are separate. This one is on the positive, that one is on the negative. They are not the same numbers. Just wanted to prove that on the number line. We think because it's negative, therefore they are the same. They are not the same. Let's check with division. So we conclude here and say minus is not associative. Let's check division. Say minus is not associative. Let's check division. Let's say 4 divided by 2 is equal to, and 2 divided by 4 is equal to. 4 divided by 2 is 2. 2 divided by 2 is the same as 2 over 4, which is equal to, this goes 1, this goes twice, so it's a half. So we've got a 2 this side, we've got a half that side, which means divide is not associative. Is not commutative, not associative. We are still on commutative. It is not, because when you swap it around, the answers are not the same, like here. But with addition, no matter how you swap, no matter how often you swap, the answer is the same. Multiplication, the answer is the same. So multiplication and addition are commutative, whilst minus and division are not commutative. Let's see when we move on to the next one. Might as well wipe it off, and then we come to associative. Associativity. Right, here we, same thing we want to see, but here we go 3 plus 4 plus 5 on brackets, right? Now we want to see if we multiply from the left, as you can see, this is the left of the equation, 3 is on the left. We want to see if we multiply this from the left, and when we multiply this from the right, so we will have 3 plus 4 in brackets plus 5. We've taken 5 outside and we've put 3 and 4 into brackets, as you can see. But it's still the same numbers, still the same operation systems. Plus, 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 plus. So we want to see if we will get what we want. Okay, let's go. So it's 3 plus So it's 3 plus 4 plus 5 is a 9. We say 9. And 3 plus 9 is a 12. Let's come this side. We've got 3 plus 4 is a 7. Remember, precedence rule, we start with what's in the brackets. 7 plus a 5 is a 12. So both sides on positive is associative from both sides, from the left and from the right. From the left and from the right, it gives us the same answer. So we say positive is associative. I'll just shorten associative. Associative from both the left and the right. Right, next one, let's go for multiplied one, multiplication, this one. So we will use the same numbers, but we just change the operation. 3 times 4 times 5, 4 times 5, and 3 times 4 in bracket times a 5 outside of bracket. And let's work out and see now. 3 times, drop it, we deal with what's in the bracket. 4 times 5 is a 20. And 3 times 4 inside the brackets, 3 times 4 is a 12 times a 5. 3 times 20 is 60. 12 times 5 is 60. So even multiplication, we can certainly say when we multiply, multiplication is an associative property from both left and right, from both sides. Anywhere we put the numbers out on the right or on the left or on the right, it gives us the answer. Let's try now and see minus. So we will say 3 minus into 4 minus 5 and 3 minus 4 into minus 5. Okay. So we have 3 minus 4 minus 5 is a minus 1. Remember, no arithmetic operations follow each other. That's why I put a bracket, because we have a minus here. And here 3 minus 4 is also a minus 1 when we drop a minus 5. Here we said if we subtract a negative number, here we are subtracting, this is a sign that tells us we are subtracting, but the number we are subtracting is negative. It is the same as adding it into its counterpart. So here we've got 3 plus 1, which gives us a 4, and minus 1 minus 5, the signs are the same. We take one sign and we add the numbers. 5 and 1 gives us a 6. So the answers are not the same. So we are saying here, they are not the same. The answers are not the same. So it's not associative. So minus is not an associative property. It is not an associative property for this one. It is not an associative property for this one. Let's go and check now. Let's go and check now division. We haven't done division. We've done positive, multiplication, and negative. Let's do division. Right, so we say 3 divided by, let me rather use something feasible, doable, easy. Let's say it is 24 divided by 12 divided by 2. And we say 24 divided by 12 divided by 2. And see if it gives us the same answers. If it gives us the same answers, then it's associative. If they are not the same, it's not. So we say 24, we drop the 24, we drop the division sign, and we say 12 divided by 2 it gives us a 6. And come this side and say 24 divided by 12, we get a 2 divided by 2. And 24 divided by 6, 6, 12, 18, 24 comes 4 here, and here comes 1. So the answers are not the same. Therefore, we conclude that division is not an associative property, or doesn't fall under the associativity law. This is what we are getting with associativity. Now let's quickly go to the next one. We've seen positive is associative because it gives us the same answer from both sides, whether we add from the left or from the right. From the left in multiplication and from the right, it still gave us the same answers. But negative and division, it doesn't balance. It doesn't give us the same answers. Let's go to the next one now. And this one we call distributivity or distributive. I'll just put a D, a big D. Distributive property. Distributive property, right? In distributive property, it's a bit different. We are dealing with a multiplication. We first take the multiplication sign and see if we can distribute it between the negative and the positive. Same thing with division. We take division and we distribute it among negative and positive. Let's go and do it. Here is what we have. We've got same 3 multiplied by, open bracket, 4 minus a 5, or 5 minus a 4, it's the same. See, we're doing it on the left, right? We also need to do it on the right. But before we go there to doing it on the right, okay, let's do it on the right. So we say 3 times 4 minus 5, and then we also say 3 times a 4, in brackets, 3 minus a 4, this one, multiplied by this 5 outside. You see, we took this one, the outside, it must be always outside, and inside we must have the signs. But this time we've taken the 3 and the 4, we put it in a bracket, therefore we must give it a negative sign because we are dealing with the negative. We started with a negative. We will come to the positive as well. So let's go. 3 times 4, we started with this one because we're splitting multiplication among these two. So now we are distributing these, right? So what we will do is say 3 times 4, close bracket, minus, we take the sign, and minus 3 times a 5. What have I done here? I took 3 and I distributed 3 among these two. And the sign has to come in between because I've distributed these two. So basically this is one term and this is one term. It's like 4 minus 5, basically, or 5 minus 4, whatever you want to put in. But I've made the 4 and distributed it among this, and I've made this one, distributed it among that. Right, so 3 times 4 is a 12, minus 3 times 5 is a 15. 15 minus 12 gives me what? A minus a 3. Take the sign of a bigger number. 15 minus 12 gives me a minus 3. And then I come this side. And this side I say the same thing. So I will say 3 times 5 minus, because I'm distributing it now from the right, minus 3 times 5 minus 4 times 5. 3 times 5, drop the minus, 4 times 5. Here is a 4. 3 times 5 is 15, minus 4 times 5 is 20. So let us see, what does it give me? 15 minus 20, take the sign of a bigger number. Since the signs are not the same, 20 minus 15 is a 5, is a minus 5, and then I the answer is like this. Right? Now let's do the positive one. Same, but it's just positive. 3 times, open bracket, 4 plus 5. And this side it's 3 times 4. 3 plus 4, sorry, because in brackets is the sign. Okay, 3 plus 4, close brackets, multiplied by 5. Right, so this is what happens. So we split now, we say 3 times a 4, close bracket, plus, open bracket, 3 times 5, close bracket. Same thing here, 3 times 5, open and close bracket, plus 4 times 5, open and close bracket. So 3 times 4 is 12, plus 3 times 5 is 15. 3 times 5 this side is 15, plus 4 times 5 is 20. It's the same as above, but different are the signs, it seems. 12 plus 15 is 27. 15 plus 20 is 35. This is what we get. So with multiplication, we just multiply, because we can spread the multiplication, we can spread among the negative and the positive, and we get answers. That's what we wanted to see with this one, distributive in multiplication, right? This is what we got. So conclusion here, multiplication multiplication is distributed between or among negative and positive. Negative is distributed among between negative and positive. Therefore, it is a distributive property. It is distributed among between negative and positive from both the left and the right. That is what we say. This is distributed among this from both the left. It's distributed on the negative. It's also distributed on the positive, from both the left and the right, from both the left and the right. This is what distributive property is. Distributivity law is all about. It's the ability to distribute the negative, the multiplication between negative and positive, both from left and from right. Let us move on now. We've done negative. We've distributed multiplication between negative and positive. Let's see if we distribute division between negative and positive. So this is what we have. Let's start here and say 60 divided by 15. Let's start with positive. Plus 5 is equal. Firstly, let us see this and see what it should give us if we put it like this, right? What it should give us. We say 60, we've got 60, we divided, 15 plus 5 is 20, 15 plus 5 is 20, therefore 60 divided by 20, 60 divided by 20 is equal to 3. Now, we come and say 60 divided by 15 plus 5, this side of a bracket, and 60 plus 15. You see, I've taken the 15 this side and put this in brackets, positive in between. So we divide this side by this 5 outside of here. This 5 comes here. So we want to see if we're dividing it from the left, what happens compared to when we're dividing it from the right. Will it give us the same answer? On the positive, we are dealing with the positive, right? So we say 60. We split now. Remember, 60 divided by 50, because we are distributing it, plus 60 divided by 5. We come this side, we say 60 divided by 5 plus, open bracket, 15 divided by 5, because we divide it from this side. So it's 60 divided by 5 plus 15 divided by 5. This side, it's 60 divided by 15 plus 60 divided by 5. Here we are. So 60 divided by 15, we get a 4, plus 60 divided by 5 is a 60 divided by 5 is a 12. 12 plus 4 is 16. So this one, it tells us it's not it, because it's not giving us that. Let's come this side and say 60 divided by 5 is a 12. 60 divided by 5 is a 12 plus 15 divided by 5 is a 3. 15 divided by 5 is a 3. It gives us a 15. 15 plus 5 is a 20, and 60 divided by 20, it's giving. Now let us do the negative, and let us see if the negative will give us the right answer. So we say here 60 divided by 15. Sorry, I want us to try something else and say 20 minus a 10 divided by a 5, and here we say 20 divided by a 10 minus a 5. I want us to see this. 20 minus is equal to, so here we have a 20 minus a 10 divided by 5 in brackets, and this would be equal, 20 minus 10 is 10 divided by 5, it gives us a 2. Let's see if we do get a 2 from these. 20 minus 60 plus 15 is 75 divided by 5. Okay, I'll come back to this one. All right, so 20 minus it is a 10 divided by 5. It gives us a 2. Now let's split this and say 20 divided by 5. 20 divided by 5 in brackets minus 10 divided by 5. Let's come this side. 20 divided by 10, open and close brackets, minus, open bracket, 20 divided by 5. So we come here, 20 divided by 5 is a 4, minus 10 divided by 5 is a 2. 4 minus 2 gives us a 2. 20 divided by 10 is a 2, minus 20 divided by 5 is a 4. We get a minus 2. Right, so here we do get our 2 here. Right, we do get our 2, which is what we got here when we said 20 minus 10, and we dealt with we did the precedence rule, dealing with what's in the bracket first, and we divide by 5 is equal to 10 and divide by 5. 10 divided by 5, because we said 20 minus 10 is 10, we divide by 5 is equal to 2. But here I want to see, because we used this one, we said 60 divided by 15 plus 5 is equal to 60 divided by 20, it gave us a 3. Now I want us to check this one, this side, this 15. When we use this one as our reference point, meaning let me use a different color, let me use red. If we say 60 plus 15, it gives us a 75. 75 divided by 5 here, it gives us what? It gives us 15. And here is this 15. Now, what is our conclusion? What is our conclusion? We conclude by saying a distributive property works on division. So we say division is distributed on both positive and negative, but only when divided from the right. When we divide it from the right, we divide it from the right. Only when divided from the right. When you divide it from the right, it gives us this number. It balances. We were dividing from the right. 60 plus 15 gave us 75 divided by 5. It gives us 15. And we split 60 divided by 5 plus 15 divided by 5. We got 12 plus 3, which gives us 15, and it balances with this one. If it is divided from the right. If it's divided from the left, it doesn't give us the 15 that we are looking for. Nor does it give us the 3 that when we divide 60, when we say 60 divided by 15 plus 5, it gives us 60 divided by 20, which is equal to 3. Still, it doesn't give us the 3. So it's only divided from the right. Let's come and see on the negative. When we divided from the right, we got the 2. 20 minus 10 equals to 10 divided by 5 is equal to 2. When we distributed 5 among 20 and 10 in the negative, we got our 2. But when we distributed it from the right, we did not get our answer. So it's only divided, it's only distributed if divided from the right. If divided from the right. If divided from the left, it doesn't work. If divided from the left, it doesn't work. But if divided from the right, it works. That is so much for what I wanted to share with you guys today. That's our topic for today, basic laws of arithmetics. We've got 3: distributivity, associativity, and commutativity. This is very important, guys. I know because it's arithmetic, you may think, it's still light work, it's not very much. It's very important because these operation symbols, operation systems, will be using them, of course, even at tertiary. When we get to things like when you get a square root of a 4, it's a 2. But a square root of a -4, it's called undefined. You cannot find the solution on this one. But there is a subject called complex numbers. In complex numbers, this is defined. You get a solution. Why am I saying this? Because we have an operation system which is a negative. And here we had one which was a positive. So if it's positive in the ordinary mathematics and ordinary algebra, it works, positive works, but negative doesn't work. But in complex numbers, both work, even on negative. We also have something called Boolean algebra. We will get to these things later, guys, when we take our course even further. It's called Boolean algebra. Here on arithmetic, we call these arithmetic operation systems. In Boolean algebra, it's not called arithmetic operation systems, but they become logic systems. Logical systems or logic systems. It's logical system. Here it's operation system on arithmetic. Arithmetic, we've got operation system. Here on Boolean, we've got logical system. We will see that where you are given an A, let me use the red. A is equal to 1, B is equal to 0. And you are told you either multiply A times B or you say A plus B. And if A plus B, that means A times B, it's 1 times 0. A is 1, B is 0. Therefore, your answer is 0 here. But here, it's 1 plus 0, therefore it's 1. And they call these true or false numbers. This is used in electrical engineering, in computer sciences. It's used in many applications, especially with computers. That's how a computer can detect. A computer doesn't know an A, a P, that's which you punch. It knows numbers. So these are the numbers we'll be doing. We also have something called vectors. We'll be dealing with vectors, matrices, all these things later. And why I'm saying these things, because these are not the only things we'll be doing as we further advance in our course, in our class. But I'm using this because they use a lot of arithmetic operation systems. They use a lot of this. That is why I'm using them here. That is why I'm including them here, to show you that don't take this for granted. And also not only to warn you of the future, but also to spare your appetite for mathematics, to know where you are going with it. It should stir you up. It should stimulate your hunger for mathematics, to know where you are going, what you'll be doing in future, to have that expectation and that desire. I know at times you just want to reach there and to get there. It stirs you up. So that's why I'm doing these things, so that you know why we need to do these things, especially why we need to understand these things. Because at times it may look like it's minor things, plus, minus, who doesn't know multiplication and division? It goes a long way. It goes way far or further than that. So please take note of this. Do this, study it, do your revision and do your work and exercise and practice until you get to know it well. Well, for that, having said that, for today, that is enough for the day. And thank you so much, guys. Please don't forget, thumbs up, guys. If you like this video, do thumbs up, do subscribe. Don't forget to ring that bell, the notification, guys. It's very important, please, because when we release a video, you become the first to get it. And also don't forget to share. When you share, you invite others. It's very important, guys. Thank you so much. Thank you for having me. God bless you.